Hello everyone, welcome back. In the last video, we talked about data types in that programming language. And today, we are going to be talking about type inference, okay? Now, we are going to take a deeper look at this type inference. We have mentioned it in a previous class. And let's take a deeper look and see what this thing really is. Now, first of all, let's talk about annotating variables explicitly. Now, the thing is this. You can create a constant like this. Let me say age is equal to 67. There is no type annotation. Remember, we talked about type annotation in our previous video. There's no type annotation. This variable now, I did not say the data, I will not include the data type. There's no type annotation. There's no explicit type annotation. It wasn't stated explicitly. But the thing is this, that is going to infer it for me. The thing is that is very smart, just like you're smart. You know that 67 is an integer, it's a whole number, right? Yes, that also knows that. That knows that 67 is an integer, just like you know that 67 is an integer. So when I hover my mouse, okay, when I hover my mouse, you can see that that is saying that age is int. It has inferred it for me. Okay. Yes, some people argue that there is no need for you to be explicitly typing the type. But the thing is that for readability, for me, I'll prefer to include the data type for readability. It makes our code more readable. All right. If I have made this thing 67.0, it will take me down to this place to know that this variable is a double. Do you understand? It has changed now. If I also do, if I say this is true, all right, the data type will infer that this data type is age. Just hover your mouse over the variable and leave it for some time for the data type to come up. So if I change the value here, that is going to infer the data type for me. But for me, personally, I would prefer to explicitly annotate this variable as a bool. It will save me from a whole lot of errors. It will save me from a whole lot of, what if I have made a mistake? I wanted to say, okay, let me remove this. What if I intended, because the thing is, as a programmer, we tend to make a lot of mistakes. It is normal. We are human beings, we are not perfect. So what if I wanted to do 34.9 and mistakenly I did 34.0? There will be no error here flagged. Okay, that will just infer that, okay, this guy wants a whole number. But maybe I wanted a double. Or let's say, let me change this thing to pi. You know, pi is 3.14. I don't know if this, I always say this, I have to take a look at the real value of pi, because every time in my video, I will always forget this. So let's say that pi is 3.14. And I made a mistake and I said it's 3. And that would accept it because it's inferring. But if I had said that, although even if I do this, it will still infer it as double. But you understand where I'm coming from. Okay, maybe this might not be the best example. Or maybe I wanted an integer and I mistakenly said 3.9, mistakenly. But if I had said int, that will flag an error, and at compile time, I'll be like, oh, okay, this is a mistake, this is an error. I will correct it immediately. But if I don't provide the type annotation, that error might occur at runtime when the application is running, and the application can crash. And that will not be a good thing for you as a developer. So make sure, for me, it's for precaution measures, okay? I just have to explicitly provide my annotation, my type annotation. But the thing is that can infer for you. That can actually infer it for you. So there will be no problem. So anyone you choose, that's up to you. Okay. Now let's talk about mutable and immutable variables. You know, this pi is a variable, all right? Whether it is constant or final or it doesn't have any of these keywords, they are all variables. But now we have two types of variables, mutable and immutable variables. From what we have done already, you know that mutable variables are the ones that don't have the constant keyword or the final keyword. It means that I can mutate this, I can change. Mutation or mutable or whatever mutable language you're going to hear in programming, it means that that thing can change. So I can change the value of pi to be 7 and there will be no problem. So this is a mutable variable because it doesn't have the constant keyword, it doesn't have the const keyword or the final keyword. So it is not a constant. So it is a mutable variable. Okay. So if you're confused with what I just explained, please drop it in the comment section. And if you have not liked this video, make sure you like the video. If you have not subscribed, subscribe. Drop your comments. Tell me what you like about this whole thing. Tell me what is confusing you and drop a comment so that other people can also get to see this. All right. So if this is a mutable variable, if I want to make this variable immutable, I will just add the const keyword and if you see now, there is an error here. It's saying constant variables can't be assigned a value. You cannot change it. It now says try removing the assignment or remove the modifier const. It's giving you a suggestion. Okay. Now, it's either I use const keyword, I use the final keyword. Two of them will work. So I cannot mutate. I cannot change the value after assignment. Okay. All right. Now, that is how you create constant variables. All right. Variables that cannot be changed. Variables that are immutable are constant variables. You use the const keyword or the final keyword before the data type to create it. But variables that do not have const keyword or final keyword, they are mutable variables. Okay. Now, letting the compiler infer the data type for you. Let's take a look at it. We have already seen it anyways. But let's say if I don't do this. If I just do this like this, there's no type annotation. So I want the compiler to infer for me. All right. So this way, compiler would know that I have mentioned this in the previous video also. Compiler knows that this pi is a whole number. This 3 is a whole number, and the compiler can infer for me. Okay. If you see, when I hover over this 3, the type is int. And if I hover over this pi, the data type is also int because it is inferring it based on the value I gave it. If I change this thing to 3.0, the data type will change here. It's not double. If I put double quotes, the data type would also change and it will not be a string. So it is inferring for me. Then this is how you actually check the inferred type in your IDE. Just take your mouse over just take your mouse to the variable name and it will give you this suggestion telling you, okay, this is it, string pi. So it's telling you that the type, you can see the type is string. All right, so that is it. Now, how do you check for the type at runtime? Right, let's say now we are not sure of the type. That has only inferred it for us, but we are not too sure. That is why don't allow, always annotate your data, your variables. Please always annotate them. Give them a data type at compile time, not at runtime. Right now, these things will be inferred at runtime. That is when that is going to know the data type of this. But it can cause a whole lot of errors. So it's better that you prevent these errors. Now, imagine that I now want to do, I want to say, I want to do plus plus, let's say, let me print, and you know, we did this increment operators, plus plus pi. Okay, anyway, that is smart enough to tell me that I cannot perform this, okay, because data type is pi, is string, so I cannot perform that plus plus on it. Okay, so but let me try something else. Now let's say we want to check the data type at runtime. We can say pi is to confirm the data type. If I said pi is string, all right. If I say pi is string, this expression, pi is string, is an expression and is going to evaluate to true or false to a Boolean variable. So if I run this code now, is pi a string? Yes, it is a string, so it will give me true. What if I want to check, are you sure this is a string or are you sure this is an integer? I want to confirm. I will just do something like this, and when I run, pi is not an integer, so it will give me false. So another thing I can do here is that I can just take this. Don't worry, we are going to talk of if statements and conditional statements. When we talk about that, you will see how we can do this in a better way. But let me say I have a variable and I will be like, I'll call it is int. All right, I'm checking if this pi is int, so I'll drop this here. Now, this variable is int will either be true or false, okay? Because it is a Boolean variable and I'm assigning this expression, the result of this expression, the evaluation of this expression. Pi is int is an expression, so the evaluation of it will return true or false. So this is how you can also use it. So when I run this, I'm going to get false because pi is not string. But if I say pi is not int, sorry, if I say is pi string, if I run this, yes, it is string. But you can see that the compiler, the IDE is giving me a warning. It says unnecessary type check. The result is always true because that is inferring that this thing is a string. The pi is a string. So you say is pi a string, it's like you're wasting your time. It will be true. So it is a way of that telling you, don't worry, this is a string. It is going to work. But when I say is pi double, that is not sure. When I say pi is string, that is sure because that was able to infer. That was able to infer that pi is a string. So it's telling you, I am very sure pi is a string, so don't bother. But when you now say pi is double, that said, I don't know, but let's check it out. All right, when we check it out, it's going to be false. So that is type inference. And then another way you can also check the data type of a variable, just like we have this int now. I want to check the data type. I can say is int dot runtime type. When I run this code now, the data type is going to be bool. All right, you can see it is bool. That's the runtime type. I can also check for pi dot runtime type. It will give me string because anything in double quote is a string. Don't worry, we'll talk about string in our next class. Okay, so that is it. Please, if you're confused in any way, please let me know. Let me know in the comment section. And if you're enjoying this, let me know what you're enjoying about this tutorial. I really need your feedback. Let me know. It will help me to serve you better. All right, so ladies and gentlemen, let's talk about type conversion. Now, let's take a look at type conversion. How do you convert from one data type to another data type? Now, let's say I have something like int, I have age, and it is equal to 67. But I want to convert this thing to a double. How do I do it? I can say double, and I say double age is equal to. If I want to convert integers to double, what do I do? I can say age, which is an integer right now. If I say age dot to, I'm supposed to get an IntelliSense here. There's this to double, okay, all right. Anyways, it's because this is a browser. It is not a Visual Studio Code or IDEs that run on your computer. So if there's some delays like this, don't panic, okay? So to double, it's a function, and this function, don't worry, we'll talk about functions and methods later on, okay? But we'll talk about that later. So now, this age dot to double will convert this integer to double, and when I print double age, it would give us 67.0. It has converted it to a double. But if I don't do this, age, if I just do this, okay, it will still, now it wouldn't work because There are two different data types. You want to brush your mouth with ice cream. No, it's saying no, you cannot brush your mouth with ice cream. You brush your mouth with a toothpaste. All right. So there is an error here. There is an error. It says a value type in can be assigned. So you have already seen this. So if you want to convert, just use the dot to double, and there will be no issues. Then what of if I want to convert from double to integer, what would I do? I will just take this double age, which is the variable, and I will do dot to int. Do you understand? So for every data type, there is you will have the method called to that data type, to double, to int, to string. Do you understand? To pull to every data type at all. So when you start writing your own custom data types, you can also provide this kind of methods too. So, but that will be later on in the course. So that is how you do type conversion. If I want to convert this to a string, I will do double dot to string. Do you understand? And if I run it now, look at what the output will be like. There will be double quotes. Okay. Double dot to string. Okay. Now, this is a string, actually. It's a string. All right. It's a string. But the double quote will not come with it. If I want to convert it to a Boolean, I don't think there is. Okay, there is no, you cannot convert from double to bool. There is no method like that because that doesn't accept it. Okay, so this is how you do type conversion. You can also convert, I can also do this 67 dots. I can convert to double on a string, on a literal like this. I can do this, but the thing is that I will have to change this guy to double, because the evaluation will return a double. Okay, so let me just take these guys out so that we don't have. Okay, you can see I can do this. I can also say 67.9. Okay, let's say I have int age and I have a value 66.9, but this is a double and it's flagging an error already. So, but I want to convert it to an integer. I will just do dot to int, just like this. So this is also valid. But don't get confused with this dot and this other dot, the decimal dot and the dot operator. We'll talk about dot operator later on in the series, and you get to understand that better. But for now, this is cool. Okay. So this is how you can do type conversion. And in case you don't understand it, if you have any question, please drop in the comment section. I'll be willing to attend to you, okay? And if you're liking this video, if you're liking what I'm doing, like the video, drop what you like about this tutorial in the comment section, okay? Now, can we talk about operators with mistypes? Let's take a look at operators with mistypes. Let's say I have, okay, let's say I have salary as double. This is my salary. Salary is equal to 78.90. That's my salary. And I have int as bonus. My bonus is equal to 7. Okay. This is just an example. Okay. Now we have salary and we have bonus. Two of them are of different data types. But what if I want to now say, okay, I want to infer. I don't know what this thing will give me. I don't know the data type is going to give me, but I don't know. So I want that compiler to infer for me. I'll use the const keyword and I will say my pay. Do you understand? I'm just using the name. And I want to do, excuse me, I want to do salary plus bonus. Now, this is an operation with mixed types. This is an operation with mixed types. All right? And constant variables must be initialized with a constant value. Try changing the initializer to be a constant expression. Okay, so it's just a warning, and we can do this. Okay, now the whole thing is because of I'm having a constant here. That is why. But I don't want to get us confused. I can just maybe use final. Let me see if it will accept that without anyone. Okay, that's cool. Okay, now salary is of type double. Bonus is of type int. So we have a mixed data types. An operator operating this, or the operator is the plus operator, the addition operator, and it's operating on two different data types. What do you think would happen? What do you think would happen here? Of course, when I run this, if I print pay, let's see the data type is going to give us. It's going to give us a double. Okay, it's going to give us a double. That's what it's going to give us. But what if I have another thing like this? Let's say times 0.2. Okay, I don't know if I'm making the best example out of this, what I want to explain. Okay, now let's say I have something like this, okay? Or let me say plus 50. But the thing is that I don't want this thing to be, I don't want it to be a double. So what I can do is that if I run this, of course, if you hover your mouse over this, you're going to see that pay is a double. But what if I don't want it to be there, I want it to be an integer. So what I can do is this, I can just put this whole guys in parentheses like this. Okay, now this is an expression now, okay, and I can now do dots. I can do dots to int. Do you understand? I know this might not be the best explanation, but pardon me for that. But if you have a case like this, all right, you can just put the variables or the expression, put them in a bracket so that it will be seen as one expression. Then after the last bracket, the parentheses, do your dot and you can use it to convert. So when we come back to this pay now, we are seeing that pay now is an integer because in this our expression now, all the variables are of data type int. 50 is int, and we have converted this particular one to int too. So please, if you don't understand this, please let me know in the comment section so that maybe I can come up with a better example, okay? Now, let's take a look at making sure that a data type. Now, we are going to see this later on, but the thing is this, what if I'm not too sure? Okay, what if I'm not too sure if this whole expression is going to be integer? I want to be sure. What I can do is that I can do as int, but it's going to throw this. What I can do is that all this whole expression, I can put them like this. And I am saying all this whole expression, I want you to convert it to int for me. So although they are saying unnecessary cast, try removing the cast, okay? But you can do this. If you want to be sure that this is going to, you want to show, you use the as int, as double, as string. If you want to be very, very sure, all right? But the compiler is telling me there's no need. There's no need. This whole expression will evaluate to int. There's no need. What if I say to double? Okay, it is no longer giving me that warning again. But I just want to be sure that I want this whole expression to be evaluated as int as double. So I just have to do that. Okay. So you will see cases like this when we start writing real code. We are going to do stuff like this. Okay. When you're not too sure, when you're writing your program, you're not too sure, we can use this as keyword to ensure that we are sure of what we are doing. So now let's take a look at casting. Okay. Casting down. You know, I told you earlier on that I can have something like this, constant, and the data type will be num, and I'll call it, let's say, age, and I can assign 34 to it. Now, the thing is this, the data type is num, and I'm assigning a value of integer to it. That is fine. If I also do 34.9, that is also okay. Now, but the thing is that num is the parent of int and double. So I can cast it down to int or double. What do I mean? Now, this is what I mean. Now, if I run this now, if I print age dot runtime type, okay, is going to, it should give us num, but it's giving us int here. I want to come up with the best example I can actually do here. I want to come up with the best example. Just give me a second. Just give me a second. Okay, so if I want to, you know, the thing is that when you're working with, I don't know, maybe the best place we can do this is when we start talking about inheritance. Let me not confuse you with this, okay? Let me not confuse you, but the thing is that when you use the ask keyword, you use the ask keyword, you're ensuring you use the ask keyword to convert, you're converting it from num to integer, okay? So you can use the ask keyword, okay? That is what we did here. We can say, when I do this, I can do int, let me say int a is equal to age as int. Now, why would I want to do this? Okay, why would I want to do this? I want to do this because if I look at this, if I say num, if I say age dot, there is a method called is even, is odd. Now, but I cannot get this method from the num class. I cannot. Okay. Okay, you can see it's flagging an error because, okay, so the thing is that there are some methods that are not available. Okay, let me do this. Let me confirm this thing I'm trying to say here. Let me do this. The thing is that it's saying that the expression doesn't evaluate to a function, so it can be invoked. Now, the thing is that age, which is num does not have this particular method. All right, but integer, this our age. Oh, sorry, this is not a method. It's not a method. I'm sorry about that. It's not a method. It's a property. Okay. Now, if I also try age dot is even, if I run this, let's see what we get. It's true. Now, but the thing is that if I want to be very, very sure of what I'm doing, I'll have to downcast it, because it's possible that double, what if I do this thing, 34.9, and I now say age is even? Let's run it and see what will happen. We'll have an error, because the thing is that this is one bad thing with type inference, okay? And again, here, we are saying the variable is of type num. That means we can assign a double, we can assign an integer. But the thing is that there are some methods and properties that are not available in double, but they are available in integer. So, but when you do this, age can take int and double. And because we are not age here, we are not too sure. So what I could do is that I could typecast age as int. And if I do age, if I put everything, this age, I put everything as this, and put it in parentheses like this. This is an expression. I want you to start getting used to this kind of top level stuff. This is an expression. Age as int will evaluate to an expression. That means I am typecasting it. I am casting it down to integer from norm, which is the parent, to the child integer, so that I can use the is even property. So if I run it now, we're still getting an error. Okay, sorry. If let's use the a that we have. It will still get an error too. All right. Now the thing is, oh, sorry. It's a different error. Now we are getting an error because this 34.9 is not a it's not an integer. So when I have this, if I want to be very, very sure that I'm working with, since this age is a norm, I'm not sure whether it will be integer or double. So if I want to be sure, I'll just have to do age as int, then I'm typecasting it to an integer, and when I run, I'm going to get it. So I know this last thing is somehow confusing, but if you don't get it, please drop in the comment section. I can do a separate video on it, or I can explain later. But once we go on with the course, you're going to understand this thing better when we start talking about classes and objects. Okay. So ladies and gentlemen, this is where I'll draw the curtain. All right. If you don't understand anything, please drop in the comment section. If you like this video, share this video, let your friends also know that they can actually do this. Tell them that they can learn programming without having a laptop. Yes, with me, that will be possible. I can help them, teach them computer programming without having a laptop. With their mobile phone or with their iPad or with their tablet, they can learn computer programming. And you can see that we are doing it here already. So ladies and gentlemen, I'll see you in the next class. And in the next class, we'll be talking about strings. Stay tuned. In the next class, you will get to understand everything about strings in that programming language. I'll see you in the next class. Thank you very much, and God bless you.